Hey guys, Double Wide 6 here, and what we're looking at here are some Shoemaker 15 amp 612 volt battery chargers for marine or auto batteries. And as you can see, I have a whole pile of these things. I actually got 6 of them, and I got them off eBay. They're broken, parts of repair. I ended up winning a pretty low bid, about $20 for everything, and I got them over to the bench. I opened them up and I had a little surprise. Unfortunately, I didn't do my research, and when I opened this thing up, it was to my surprise that there was no large transformer inside here. It has all these real small electronic components. So I kind of got these things thinking that I would use some of the parts. They came with pretty good battery terminal crimps or connectors, and I wanted to get the transformer. If it had a big transformer like a microwave, I want to get some of those transformers because I was going to make a foam cutter was one of the things I wanted to make, and also a rope cutter. I was going to take a transformer and put like a light dimmer on it and use that to heat up a blade that I could just take rope, and it would cut the rope, and at the same time it would burn the ends of the rope. So anyhow, I ordered these things. They came, they didn't have that transformer, and now I'm kind of out of luck. So I figured for this video I'll just show you a little bit of the troubleshooting that I do on electronics when something's broken around the house. I usually take the time to open it up, if anything, just to see what it looks like in there. But I'll show you some of the things that I look for, you know, as far as how to repair electronics. Alright, so if you have something that's broken, say a TV device like this, what you'll notice is that there's extra wires in here where other boards are connected. I don't have the power on, so I'm just going to carefully disconnect this. You'll notice that the top of this charger has a separate board that works these buttons and stuff. So I'm going to disconnect that. And the reason I do that is because if the unit powers up and it senses, you know, let's just say a short on the board here, they're smart enough to have it shut itself down. Okay, it's a kind of a safety fire prevention technique. It doesn't want to overheat and cause a fire. So by unplugging that, a lot of times you can isolate what's wrong. So say the problem's with this board, maybe when I unplug it, I can find a voltage over here. Okay, there's also a little DC powered fan, so we can unplug that as well just to make sure that there's no problem there. Alright, so now I'm going to plug this thing in, and I'm going to take my meter and we're going to put it on DC voltage, because the way this thing works is AC power comes in on the left hand side, and then over here it's DC. So I'm setting my meter to DC, and right now it's in millivolts. So I'm going to switch the range here, and oops, we're going to grab our probes, and what I want to do is I want to see if I'm getting any power out of these pins. So I'm just touching in here, and I'm going to go through and I'm going to see if I pick up any voltage. And we're looking to get about, usually anything less than like 5 volts, okay, but it would have to be, you know, more than a volt. Something like 3 to 5 volts from any of these pins would indicate that we have power coming through here. So just by that little test, I can tell that this board is the one that's not working. This one seems to be working from what I can tell, or at least, you know, I'm going to troubleshoot this one first. So the next thing that you want to look at is you want to make sure that your 120 volts is coming in from your wall outlet, which seems pretty obvious. So I took the probes and I checked this. It's all unplugged now, and I have my 120 coming in, but that power is not coming through this transformer, and it's not coming over to the other side, so I'm assuming the problem's on this side of the board. So what I'm going to do is unplug some wires that unplug, and we're going to take a closer look at the board. So by unplugging everything, it definitely gives you a better view of the board. As I remove this wire, you can see it has this thing wrapped around it. If I look in here at these resistors, you can see they're actually burned. So we're definitely on to something. So these resistors are definitely shot, I would say, but we can pull them out and test them to make sure. Now, with a visual inspection, you know, I don't do electronics every day or anything, so I don't know a whole lot about it, but usually I'll open something up and just take a quick look around. These big guys are capacitors, and a lot of times companies use cheap capacitors, and they either bubble up on the top, like become convex, or sometimes they leak fluid out of them. So that's something to look for. If you see a capacitor like that, then you know you could probably change the capacitor. So they go bad a lot. The other thing that goes bad a lot are diodes, and in here is a diode, so we can test those pretty easily. We can also test the capacitors pretty easily. Another thing to look at, a lot of times it gets popped, is the fuse. Okay, now that I know it's a fuse because right there it says F1, so it looks like it's like 5 amp 250 volt fuse, and you could get that easily online, and that we can just run a quick continuity test. This thing is another capacitor. It's a different type of capacitor, but sometimes these crack if they're bad. So if you ever see a crack on them, that can be a sign that they're shot. But capacitors should have continuity through them, and I'm going to just show you how to basically troubleshoot some of these components. Probably what I'll do with this one is, since I have like 6 of these things, I'll pull some resistors from another unit and solder them in there and see if that takes care of our problem. Overall, this board looks like it's really well made. The capacitors, you see this gray stuff, that's actually glue in place. And I did talk about leaky capacitors. You have to make sure it's not glue. A lot of times they'll use like hot glue, like this IC down here, which is an integrated chip, has glue on top of it. It's not because it exploded. And these things are heat sinks. They're just aluminum, and they take the heat out of these chips so they don't get too hot. So if they do get too hot, you can get like a cold solder joint. So if you flip that over and you look on the back, you can look at these solder joints and make sure that there's no crack real close to the post of that thing coming down through there. So any ICs like this thing, you want to check that they're not getting too hot, or anything that's hooked up to a heat sink. You can look down at the bottom, and if they heat up, it won't be making a connection, and then what you can do is just take your soldering needle and you can touch it up. With even a closer look at this board, the bottom of the board, you probably can't tell, but it's varnished. It has a very thick coating on it, so you know, it makes it very hard to test the components in the board, because you have to scrape away this component or this film that's over it. So one way that I've done this is, if I really want to quickly test something, I don't know if nail polish remover will remove this, and maybe one of my viewers knows what'll do it. You could post it in the comments, but you could take a little handheld, this is a handheld engraver. Thing's actually pretty awesome. But if you just scrape a little bit, just like that, okay, that'll allow you to get your probe right in there and test different components if you need to. So that's just a little tip. And for the purpose of this video, I'm going to switch to a different board. I have another board just kind of laying around, and this one, like 90% of the boards that you get, doesn't have any film on it. So it's going to be easier for me to show you how to take a component out of there and how to test things, because I don't have to scrape away all this varnish. Alright guys, I'm going to show you how to resolder a post where the solder joint might have got cold or cracked. So here's a heat sink. I'm going to flip this thing over, and I'm just going to figure out right where that IC comes through. It actually comes through right here. It's these three posts. So we'll just zoom in on this. I'm going to mark it right there, and let's say that, you know, one of those is cracked, and it might seem like a kind of stupid thing. Oh, by the way, you can take like a little loop like this and take a close look at it in a well lit area. But all you have to do, and I'm taking my soldering needle, and you go up to the point where you see a loose joint or a crack, and you can just put your soldering needle on there, and you can see that solder melted and it resealed. And that's all you'd really have to do. If you wanted to, you could get in there and just add a little dab of solder like that, and that'll make sure that that makes contact. Now that seems very easy, but what happens is, you know, if something's not making contact, it's not going to work. I had a 2001 Ford F-150, and the mileage would stop showing up on the dashboard. It was digital, and I pulled the board out behind all the gauges, and I took a look at it, and sure enough, I found 3 spots on that board where there were cold solder joints, and all I did was touch them with the needle, and it completely fixed it. And these are the things that are made in manufacturing, like these boards. So if a robot is soldering them and it's not doing it right, it's going to be wrong for everybody's truck, okay? Because the robots do everything the same. And you'll notice, like with flat screen TVs and that you repair, if you have a TV that goes bad, you can Google it, you can look up a video on YouTube. There's even a guy that I bought a book from that shows all the different models of TVs and what goes wrong with them. And, you know, literally you can just go into the board, pull out the individual component that's most likely wrong, and change it. I fixed about, I don't know, maybe 4 or 5 TVs that I have in my house that just had simple components that needed to be replaced. Also with TVs, if you narrow it down to which board is wrong by unplugging and figuring out where you have power, a lot of times, like right here, this one lists all the pins. It says pin 1 down here, pin 12 up there, and a lot of times on TV boards it'll list the voltage that you should get on each of these pins. So if you're getting the right voltage out of a board, you would know that that board works. And you can order the individual board, you know, maybe $50, and you can get your TV back up and running. Alright, now I'm going to show you how to simply remove a component. So let's say you have a capacitor that's bubbled up or something like that. All you'd have to do is just flip the board over, and you want to figure out where your capacitor is and heat it up with the needle, and just pull on the other side, and there we go, that just popped out. You could do that with a diode, you could do that with a resistor, you can do it really with any component. And if you had something huge like a big chip that you wanted to remove that had a bunch of pins, you can actually just use a heat gun to heat up the solder. Alright guys, I'm going to just real quickly take you through some of the basic testing that you can do. And this is the type of thing that I'll do if I know nothing about anything. Pull the board out, and visually inspect it. Okay, down here, I think I mentioned this. This is a fuse, and I know it because it actually says F1 next to it, so it's fuse 1. The fuse, you just want to do a continuity test. So our fuse is running right here. Okay, so we're going to turn on our meter, and we're going to set it from diode to continuity. We'll take our probes, and I think this is our fuse from here to here, and we should hear a beep. Well, that's another problem. So just replacing those resistors, looks like that fuse is popped. Let me check this other board real quick. On this board, yeah, most every board has a fuse. Sometimes they're ceramic, sometimes they look glass, like the ones that work in a car. You can't switch the glass ones from a car with the ceramic ones. You need the ceramic ones. But once again, this thing says F01, so that's fuse 1. And a lot of times with electric boards, they you know, they label the pieces. There you go. So there's a good fuse on this board. Okay. And a lot of times, you know, you might find a blown fuse and you can change it, but that won't fix it, because like on that other board, the resistors were burned out. Okay. Next thing we're going to talk about is testing a diode. So diodes, let's look on these boards. This one has, most boards have a diode. They're small devices. Alright, so I'm gonna, right here's the diode. I want you to look at the meter. Right now it's set on continuity, so I'm gonna switch it to diode. Okay, and the negative side of the diode's called the cathode, and that has a line there. So if I go from that stem there to this stem, if you look at the meter, we're getting about half a volt. Okay, 0.489. If we switch our probes with our diode, we should get 0. So what the diode does is it lets current flow in one direction only. Okay, so this is a good working diode. To properly test the diode, you should really loosen up one end of the solder joint and go across it, because it's possible to get a false reading that way, but this is just a quick demo. So that's how you check a diode. If you look on the meter, once again, this is that new meter I got. I really like this thing. This symbol right here with the arrow and the stop, that's the diode symbol. And when you get up top, it tells you that you're in diode mode. And if you ever have your probes hooked up wrong, these light up down here to tell you that there's a problem, or if something comes loose, that just lit up red. And that's really nice, because once in a while you get your probes in wrong and get a false reading. So next thing I want to talk about is a capacitor. So here we go. For a capacitor, here's what a capacitor looks like. This side's the cathode, or negative side. It's always marked like that. On the board, oh, let's see. I don't even know where I pulled this thing out of, but here's a blank spot that didn't have one put on it, because when they print these boards they can set them up differently. C is for capacitor. There's a plus sign for your positive lead. So there's polarity with capacitors. So if you pull one out, you gotta make sure you get it in there right. To test one of these, you need a capacitor meter, a meter that tests capacitors. I have an ESR meter, and this thing will actually test a capacitor in line, so you can do it right on the board. So here's how it works. You can turn it on, and it'll show you the ESR value, which I think is a value of resistance. Like, there's plates inside the capacitor, and electric material that transfers a charge through those plates, and over time it can cause more resistance, and your resistance through the capacitor can rise, and it can cause heat, and that's why capacitors bubble up, and sometimes you know, like liquid spews out of them. Anyhow, this meter, we can put this on here like this. That's the negative side, and this is the positive side, and it should give us a capacitance reading. Just turned off. So it says hello. Now, hang on, I just screwed it up because it calibrates. You can't have it hooked up. Let me get a, here's a new capacitor that I know works. I don't even know if that one works. Alright, so it's on ESR, that's capacitance. Now it's going to show us both capacitance and ESR. So here's the negative to the cathode side, here's the positive, and it's showing a capacitance of 466. Alright, that's 466 microfarads. This thing's rated at 470 UF, that's microfarads. So you can see we're within 5%. We're at 467. Now our ESR is 0.08. This thing came with like a little chart. So what do we have? How many volts this thing? Sorry. 35 volt. So if we go to 35 volt, which they don't have, oh here it is, 35 volts. A 35 volt 470 microfarad should have a reading of less than 0.1. We're at 0.07. So that's a new capacitor, but it's a good one. So that's how you check a capacitor. You need a capacitor meter to do it. Now, let me find a resistor. Alright, so last component we're going to quickly talk about is a resistor. And basically resistors have bands on them. There's usually a gold or a silver. That should be on the left. And then there's a system. You can look it up online. You can, each different colored band accounts for a different value, and you can determine with a chart what size resistor it is. So to test this one, alright, if it's on a board, you should actually loosen up one leg so you don't get like a false reading. So desolder a leg, okay, and then you take your meter. You're going to set that thing to ohms, which looks like an upside down horseshoe. Hopefully you can see the meter. And what you want to do is set it on there, get your probes touching, keep good pressure on it, and you can see we're getting about 20 kilo ohms. As you see, it says K ohms. I don't know if you can see it, but that's how you can test a resistor. Now if you ever have a resistor like this thing that's smoked, you want to replace it. Alright, don't leave it in there. There's a sign that something's wrong with that. So that's like the basic troubleshooting that I would do. You know, I'm not gonna get too in depth into, you know, how to do everything on here, because I don't even know how to do everything. But those are the basic things that I would look at, like the fuse, the capacitors. Those are easy fixes if something goes wrong. You know, so I think it's worth popping things open and taking a look once in a while. If anything, it's a little bit fun. So anyhow, I'm double wide 6, and I know I already mentioned that I just got this meter. If you're interested in it, I'll put a link to it on the bottom of the video, and hopefully over time I can get some of these things working. I was thinking it would be nice to have a couple of these, maybe like 2 of them to have in one in my garage and one in the shed, because these are actually smart chargers, so I could charge a battery, where I have an old charger down here that it won't turn itself off, but these things actually will. So hopefully I can get a couple of these working, and whatever, it'll keep me busy in the winter. So anyhow, I'm double wide 6. Thanks for watching, and we'll see you next video. Happy New Year.